This question from 2017 AP Physics 1, and the question states, a physics class is asked to design a low-friction slide that will launch a block horizontally from the top of the lab table. Teams 1 and 2 assemble the slides shown above and use identical blocks 1 and 2, respectively. Both slides start at the same height d above the tabletop. However, Team 2's table is lower than Team 1's table. To compensate for the lower table, Team 2 constructs the right end of the slide to rise above the tabletop so that the blocks leaves the slide horizontally at the same height h above the floor as it does Team's 1 block. See the figure above. Both blocks are released from rest at the top of their respective slides. Do blocks 1 and 2 land at the same distance from their respective tables? So the answer is yes or no. And when you answer questions like yes or no on AP exam, just answering correctly yes or no does not give you points. You have to do the explanation. Because they say that there is low friction when they slide down their paths, we eliminate the friction to be the effect of what is just happening. But what you can do is to look at the potential energy right here, potential energy of the one and potential energy of the second one. And the potential energy between where the block is starting and where the block is ending is greater for first table. Potential energy where the block is starting and where the block is ending is less for the second table. So that means the kinetic energy of the second block at the bottom is going to be lower than the kinetic energy of the first block with the first table. So that means the velocity of the block on the first table is going to be greater as it leaves the table compared to the block of the second table when it leaves the table. What's going to be the same for them, so V1 is going to be greater than the V2. What's going to be the same for them is the time it's going to take to land on the ground, because they're coming from the same height above the ground. But because velocity of the first one is greater than the velocity of the second one is not going to land as far as the first one. So when they ask the question, both blocks are released from rest at the top of their respective slides. Do block 1 and block 2 land at the same distance from their respective tables? The answer is no, because the energy for kinetic energy of the second table and the velocity of the second block is lower than the ones for the first table. For the second part of the problem, in another experiment, teams 1 and 2 use tables and low friction slides with the same height. However, the two slides have different shapes as shown in the pictures. So for both blocks, if both blocks are released from rest at the top of their respective slides at the same time, which block is, if either, lands farther from their respective table? So in this case, both blocks have the same potential energy that they start with, because by the time they both reach the bottom, they travel the same height down, but they didn't travel the same path. Because they did have the same potential energy. That potential energy, if we ignore the friction, if no work done by the friction was included in the problem, and they stated that it is at low friction slides, the kinetic energy of both blocks is going to be the same by the time they reach the bottom of their paths. So that means their initial horizontal velocities when they leave in the tables are going to be the same. And because their velocities are the same, and the time to land is the same because they're coming from the same height, they will land the same distance away from the table or from their respective tables. And then for the last part of the problem, they ask you which block, if either, hits the floor first. So there are a few videos on Brachistochrone curve, and I'm gonna attach the links to this video as well that are worth to watch. And it was still in I think early 1600s when Galileo tried to solve similar problem with a path, which path will take the fastest to get to from one point to another when the ball is rolling, and he found that the fastest would be the Brachistochrone curve. And this Brachistochrone curve looks the way the first block is. The path of the first block, not the second one. And so if you look at these two paths, the first block will reach its bottom before the second block will reach the path. So that means even though they have the same velocity when they are leaving the tables and they will land the same distance away from the table, the block 1 will reach the ground first because its path, the Brachistochrone curve path, allows the block to reach the end of the table faster before the second block reaches. And again, watch the video in the links about the Brachistochrone curve. And that is all I have for 2017, this type of AP Physics question, AP Physics 1 question. And I hope this was useful and helpful, and thank you for watching, and I hope I see you in my future videos.